Concept number 9, Design and Construction to Operations. The tools used to demonstrate the concept are not selected as the only solutions possible, but to illustrate what type of an ecosystem could develop in the next version of DMLSS once a services-oriented architecture is enabled. Other vendors are encouraged to demonstrate how their solutions fit into the DMLSS ecosystem. So in here we're going to talk about several workflows. One is we're obviously focusing on DMLSS and operations and maintenance, but we also want to show that as a project is defined, for example, renovating an existing facility, using the DMLSS data as a starting point and the CAFM data as a starting point, combining that with the SEPS output defines a requirement for a new facility. So having that type of data accessible both in web services. So if SEPS, the Space and Equipment Planning System data, becomes web service enabled, and designers can use that to start a project or to use that to expand an existing building a renovation or renovation of an existing facility or adding a new wing. Connecting that with SEPS and DMLSS makes it very powerful, and also using BIM or building information modeling. So here we're showing a program requirement going into web-based BIM application to do quick blocking and stacking, and then pulling that data into other applications like Revit and DProfiler to start doing the design work itself. So here let's assume there's two different scenarios here. One, this could be the requirement for a new facility in a blocking model with all the equipment that might have come from SEPS. Or this could be an existing facility being managed in DMLSS as a CAFM system that has the data accessible for CAFM in DMLSS 4.0, but also could be extracted to use this to do a renovation. So for example, to add a new wing to this hospital, or to gut the floor and start over, or to take out half the rooms and redesign them, etc. Having this at your fingertips as a designer is incredibly valuable, because right now the status quo way is a lot of manual digging to find existing conditions. So the intent here is to demonstrate that having the DMLSS data accessible both for operations and maintenance, but then turning that data around and using it to do planning and renovation work with that. And this can start in multiple formats, but here we're showing it in the Onuma system as a blocking and stacking model. It is a quick design model with the existing facility data. So let's say this floor there are issues with the mechanical systems or with other parts of the layout that might need to be renovated. We can do a quick blocking model in the BIM itself, either the healthcare facility staff, or this could be handed to the design team. This exact same model and the data that came from the CAFM and CMS data from DMLSS 4.0 is in the model before it gets handed off to the design team. So in this scenario, we're taking it from the CAFM model, handing it off to the design team as a Revit model. The exact same IDs and attributes can even be carried through. So you could say, this is everything we know about our facility. We've been using DMLSS 4.0, and the data about the day-to-day operations is now embedded in the model that you would need to start a design process. So this is Revit on the right side with the exact same data that came from the CAFM system now in Revit. Now the design team takes off with that and starts doing their work with all the elements. Notice that it goes all the way down to the equipment level. So it's all about moving the data back and forth through this process as you're going through the design process, and then even checking it back in. So from a web services perspective, in Revit there are APIs, and there are several tools out there that use these APIs that can connect to other servers, model servers. So within Revit or within Navisworks is one example. You can be designing as an architect with the requirement that came from either SEPS or from the DMLSS data, the CAFM data that was handed off to the design team, and now you're designing in Revit as an example. And that Revit model has an API that connects back to a web service database. So it could be the client's or the owner's requirement model. And now in Revit, with in this API, in this case we're actually showing the Onuma system API in Revit, but there are other APIs that work in Revit as well too, that does a comparison between I'm designing this from Revit, how does it look like compared to what the owner asked me to do, and color code all the spaces in the floor plan, red or green from delta plus or minus. color code the create a report and do the same thing, and then even drill down to the equipment level. The bottom one on the right is red and blue is equipment that was required and equipment that might be missing, as one example. So you can quickly see as you're designing the model in real time by linking through web services to a requirement database. And that's the concept here, is that you're able to use in the future of DMLSS is web service enabled, and the project requirements is then shared with the outside team. Obviously the security layer and everything that we talked about in other parts of this presentation come into play here, but conceptually we're saying that this consultant is given access to certain data for their project and that alone, and they're checking that against our requirements. And that same data should flow all the way through. So for the previous screen where we had BIM on the web, here BIM on the desktop in Revit, or even in Navisworks. Navisworks also has an API. Several vendors have APIs built into Navisworks that connect to their server, as one example. And that same approach can be used to connect to max.gov's another server that has the client and the owner requirements. Once the design progresses through this, the goal now is to take the data of the completed model, the as-built model, and move it into operations. There are several ways of doing that. One way that's being used quite widely right now in the industry is COBie, Construction Operation Building Information Exchange. So from the servers, you output a COBie file and you can import it into CAFM and CMS systems. Or once we get web services enabled here, you can even do it, connect it live. And this concept is actually showing how that is already possible. You can actually have a server getting the data from the completed design, delivering it back into a format that can be used for CAFM and CMS. And the interesting thing about this particular step in the process is the very detailed design and construction model. In theory, yes, you can use this for facility management and operations, and certainly we encourage that, but it's not required to do that. Certain CAFM and CMS systems are only interested in certain aspects of the BIM, and if you keep it lightweight, then you can continue to maintain it in CAFM and CMS, and this particular as-built model becomes kind of a model of record that still has the same IDs, so you can track it during operations and maintenance, but keeping it flexible like this, so it's not embedded in one tool, it's not all or nothing, or it's really up to where the owner's needs are for data and operations and maintenance. And that's something that's important to establish. What do we need from the design and construction team that can be used in operations and maintenance? Defining that in COBie is a perfect container to transfer that from the design and construction BIM into CAFM and CMS systems. And using web services as a goal for a 5-year roadmap, there are ways to even automate that even further, and the technology is there today, just a matter of deciding when to scale it up to the entire portfolio.